I already checked the names before. Okay. Yeah. Today we have a presentation from Daniel. The presentation, it's about automated builds with continuous integration and continuous deployment. Actually, this is a very, very interesting topic. Maybe you do not consider that interesting right now, but be sure that if you are good at that and you can do that, it would be way easier for you to get a job in the video games industry, because there is actually not many people specialized in this field, and it's a super important field. When I was working in electronic arts some years ago, that was part of my job, and actually there was a big request of engineers specialized in that field, in builds and continuous integration, and well, and controlling all the build process for a game, because it's a really complex topic, and there aren't many engineers specialized in that. So it's really important, really, believe me. Okay. Did you follow me? Hello? Can you hear me? Oh, okay. 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 But first of all, Daniel, Miquel, Daniel, are you there? Okay, Miquel, are you there? Okay. I send you, and I also share in the campus, a document called Project Guidelines. Did you check that document to work on your research, to do your research? Well, actually, that message is for all of you. Okay. So, okay, good. Yeah, Daniel, you can fix it later. Please, can you open the document and check your GitHub? Ah, that's it, Miquel. Very good. You notice it, that you are not following the rules. Yeah, you seen that recently. I've told you that several times. It's incredible. Daniel, you also check the document. Research project guidelines. Please follow the rules. When if you didn't follow the rules, when I check the research to give you the mark, that's 0.5% of the mark. Just keep that in mind. All of you, not only Daniel and Miquel, all of you, check the guidelines, check the project guidelines carefully. Okay? Okay. So, let's start with Daniel. So, where is Daniel? I'm gonna give you rights to present. Daniel, you can share your screen or the presentation itself. Oh, okay, that's it.
Can you hear me?
Hello?
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 Okay.
Yeah, we can hear you. We can.
Nice. Can I start?
Sure. Everybody can hear Daniel? Yep.
Okay.
Yeah, perfect. Danny, you can start.
Hello everyone. Today I'm presenting automated builds, and firstly I will tell you some theory, and later I will tell you a program that will be very useful.
Wait a second, please, Daniel.
Okay.
Just a second. Yeah, just a second. Okay, let's go. Yeah.
First of all, the automated builds are a practice of automatic building a software that typically is done on every commit. You can with this you can understand very quickly if any commits are causing issues, and if it's done correctly.
Okay.
Okay. The types are, the first is continuous integration. Is a development practice that requires to all developers to integrate the code into a shared repository more than one time a day. Every check-in is verified by an automated build. Vale. Okay. The benefits are that you won't have to have long and tense integrations. They increase the visibility, enabling reader communication, catch issues early, and nip them in the boot. Spend less time debugging, build a solid foundation, stop waiting to find out if your code is going to work, and reduce the integration problems. The next automated build is continuum delivery. That is the ability to get changes of all types, including new features, configuration changes, bug fixes, and experiments into production, or also into the hands of the users. That's
You're going a bit too fast, I think, Danny.
Yes, sorry, I have never presented into internet.
Yeah, if you can go
So weird.
to the previous one, because you are going a bit fast. Yeah, let us some time to at least read.
Yes. Sorry.
Or explain it more slowly.
Well, can I pass to the next?
Yeah, but okay. Everybody understood what it's continuous delivery. Everybody understood what continuous delivery means. Yeah. Actually, there is some people that don't understood it. Actually, I didn't understood it. But can you explain it again, please?
Okay. The continuous delivery is a process that gets us the ability.
Yeah, I took notes also, Enrique. I take notes also. So yeah, continue, please.
To get changes of all types. That means that includes all new features that programmers are adding, the configuration, and all the bug fixes, and it in a safely and quickly way, so it's faster than do it normally. Okay. The benefits of continuous delivery are that the releases are in low risk. That means that the software is more like painless. It's faster to go to the market. You have a higher quality. It costs less. Your final product are better, and your team will be happier because they are not spending the same time as doing normally. Okay, and the third is continuous deployment. That is as a kind of strategy for software releases that any code, the commit passes by a testing phase that all that changes makes are visible to the software users. Okay, and these are some of the benefits. Eliminate DIY for the continuous delivery and increase the focus on the product. Automate the repetitive tasks. Make deployments frictionless without compromising security. Scale from a single application to an enterprise IT portfolio. Connect your existing tools and technology into a harmonious workflow. Integrate teams and processes with a confined pipeline. Create workflows across the development, testing, and production environments. Provide a single view across all application and environments. Ship both cloud native and traditional application in a unified pipeline, and improve the productivity. Okay, I will explain now a program that is very useful.
Actually, a player was not on the research list.
Well, it's for automated builds.
In previous years, but not in this year.
But it's for automated builds also.
Okay, yeah.
Right.
Well, actually, it's deprecated. I mean, it's deprecated. So keep that in mind. But that's not the focus, because you don't have to use that one. You have to use GitHub Actions. But yeah, continue, please.
Okay. Well, this is a program that it makes for you that the automated builds and gives you the feedback for all builds that are you doing. Okay, and if I can, I explain you how to configure it. Okay, firstly you have to sync in with GitHub, and it will link in a player with GitHub. Once we have synchronized the application, we can go to that player and create a new project, selecting the GitHub like have done it. Later, when we have a project in a player, every time we make a commit, we'll try to make a build. It can fail if the configuration is not correct. So I will explain the configuration. It's very easy. Okay. First of all, there are two ways to configure it. The first one is in the same app layer, selecting the setting options, and the other one is creating an YAML file named applayer.yml. Something that I will remark is that AppLayer will give preference to YML file before the project settings. So be careful with that. And the project settings is divided in different sections. The main one is general, and that there the most relevant option that you can configure is the build version format that will increase every time a build is done. And another useful setting is that you can select from which branch you want to make the build every time a commit is done. Here you have an example, the general option of your project. The next important settings is that you have to select the Visual Studio that you are using. In this case, I'm using the 2019. If you are using the older version, so you can select it. But you must. Okay, another option that you have to do is to go to deployment and add a deployment. But you need to get a token that is like a password to work with that. That I here have to go to the well, I put the link in the README, but have to go to the developer settings to generate a new token that later you will to no, well, I will explain. Okay, you have to put the public repo to generate it, and you need to put it because it won't work. Okay. And once we have this token generated, you have to encrypt it, okay. And the result of this encrypt is you have to go to the page that we were before and put it your token. Okay. We should go back to the app layer, and now the app layer can access to your GitHub. And remember that you need to have a README, a folder with, well, you know all that. Okay, now in the section of the build, you have to put an script that is this script, okay, and you have to put your project name, your solution name, and in this directory. here, like is in the image. In my case is resets, and my executable is motor 2D. What? This is to select where are all the assets that is in the game. And finally, we can turn on the notifications. For example, if any commit goes wrong because there is something that doesn't work, this program will notify us that it's not working, or if is right done, it will notify us. And I think it's all. This is all.
Yeah?
Yes.
Something else? Any last slide or?
No.
Okay. Did you implement it, the continuous integration system in your project? Or
No, not yet.
A repo to show how it works?
No. I was testing a little bit, but with other.
So the rest of the class have they have no template or anything to start with.
What?
I mean, the rest of the class has to implement continuous integration and continuous deployment. I think it's a requirement.
Yes.
Do they have some reference to do that? Do they have some starting material to do that? Or they have to create it from scratch?
No, I think with having this, this program.
Yeah, no. Actually, why did you choose Abbayor?
I think that is.
I mean, I think in the research project.
Yes.
It was specified that it had to be GitHub Actions.
Oh.
I mean, Abbayor, it's going to disappear briefly. I mean, it had to be GitHub Actions. Abbayor, it's a thing of the past. I don't know what.
This program is. I was more understable.
But did you try implementing Git? Because as far as I know, GitHub does not allow you to create new tokens for Abbayor. I mean, maybe I'm wrong, but
no,
well,
it allows you.
It allowed you. Okay.
Yes. Because I tried.
Okay. Well, in any case, you should. That's for the rest of the class. You should use GitHub Actions, not Abbayor. And actually, it's quite different because you don't have that kind of dashboard to configure things. You have to write the YML file directly. You have to write the code in the YML. So, this research project lacks a lot of information for the rest of the class. A lot. Now, all the projects have to implement their own GitHub Actions system, and they have to do the research again. I'm afraid. So.
My bad.
Yeah, you should. You should have focus on GitHub Actions and not in Abbayor. Anyway, the rest of the class, or at least prepare a project or set up a project to show how it works, to show a demo. Questions. That's a question for all the class. Did you understood? You can close the screen, Daniel, if you want.
Okay.
For all the class, did you understand how it works? Did you understand what is continuous integration and what is continuous deployment? Everybody, did you understand? Anyone did not understand or have some questions? Keep in mind that you have to implement it in your projects. It's not an easy topic. Yeah, well, yeah, Angel, you will look into it yourself, but that's for sure. But the idea was to have a research as a guide for you to do it, or at least have some template, or at least have some already set up scripts to do that. As I said, it's not an easy topic. Well, about the concept, did you understood what is continuous integration? Please raise your hand, someone, and explain it to me. Continuous integration. Anyone? Please. Well, do you have questions for Daniel? You can also ask questions to Daniel. Actually, Daniel is now the expert on this field, so if you have problems in your project with that, probably you should ask Daniel about it. Nuria, raise your hand. Okay, Nuria. Hello, Nuria.
Hi.
Hello, Nuria. Yeah, tell us.
I can try to explain it, but
Yeah, it's okay.
I mean,
Yeah.
I'm not very good at explaining myself.
Don't worry. If there is any doubt, I can explain it later.
So what I understood is that in order to have certain builds, or in order to have like regular builds, you have these deployments. So they will be done automatically, and well, this makes it that this way the developers don't make mistakes and to have this continuous build so you can follow the process. I don't know if I explained it well.
Yeah, it was kind of. You missed some detail, but yeah, it was kind of.
I mean, it was fast, but I think that's the main concept.
Yeah, and what's the difference between continuous integration and continuous deployment?
Okay, that I think I didn't understand.
Yeah, okay. Daniel, please, can you explain us what's the difference between continuous integration and continuous deployment?
Okay, I will say that there in both there are a progress of that is something is automatic and something is manual. And for example, there are I don't know which progress was the difference, but some progress are not manual like in continuous integration. I don't know how to explain it. I don't know. Yeah.
Okay.
Not very good at talking in English.
So maybe it would be more like the continuous deployment is done by the app that you showed us, and the continuous integration is done by developers, as Pau Pedra said. Something like that?
Not really. Anyone else got any idea or can try to explain it? Rick? Mark, about your assumption, it's not correct. Not completely correct, but it's approximate. Enrique, yeah, you're right. Yeah, that's it. Well, it's a very simplistic way to understand it, but yeah, it's correct. Okay, so I can give you some insight of what's that. Yeah, continuous integration means that every time that some change is pushed into the repository, it could come from a commit, from a pull request, from a branch integration, whatever. There is an automatic mechanism that not only compiles the project to verify that the project compiles, but it could also launch a battery of unit tests or a battery of tests over the code to verify that everything works, that all the functionality that you want to test keeps working. Right? That's the continuous integration mechanism. Did you understand that? Did you have any question? Do you have any question? No questions. It was clear. Continuous integration, what it means. Okay, Adrián. Okay, Adrián. Okay, I'm gonna repeat it. Continuous integration, it's an automatic system in your code repository that every time a change is made in the repository, it automatically compiles the code and runs, well, it could or could not run a unit testing system, a battery of tests over the code to verify that everything works. That's it. Yeah, well, usually you create something that is called unit testing, but unit testing in video games, well, it's kind of a special thing because it's not that common. It's more common in applications that usually like software applications, desktop applications, not in video games. For video games, have a while loop that generate frames. Well, having unit tests in video games, it's a bit complicated. But usually the continuous integration for video games just compiles the code to verify that everything compiles. But yeah, you can also have some unit tests to compile or test a specific part of code and the tests have to be created. Obviously, creating the test, it's a lot of work. And does it test in systems with less resources? What do you mean? No, Pau. It just compiles. Usually the compilation it's done in a server. I mean, even GitHub Actions or also AppBayor or even Travis, that are different continuous integration, continuous deployment systems, have their own machines that are quite powerful to be able to do that process super fast. Right? Wait, we haven't finished yet. We just talked about continuous integration. What about continue? Yeah. They can continue for different operating systems, for different configurations, debug, release, x86, x64, ARM, different kind of CPUs. Wow, yeah, you can do a really big battery of tests. I mean, you can compile your code in, let's say, 100 different configurations to verify that everything works as expected. Yeah, that's the interesting thing, yeah. Okay, so continuous deployment. What is continuous deployment? We talk about continuous integration. What can we say about continuous deployment? Anyone? No one? What? Oh, someone. Pau.
Hi.
Hello.
I'm guessing, and this is it's when it's adding the game side or the release side of to the continuous integration. So adding and preparing all the assets or all the required files for a game to ship.
That's it. Perfect. Yeah. Actually, continuous integration. Well, actually, Guillem said it. It's related to the release. Continuous deployment usually follows a continuous integration run, and it packs all the data and all the assets into a zip or into an ISO or into an executable, well, whatever. It packs everything to generate the final release. And actually it releases it. The continuous deployment system can automatically release for you. I mean, not only pack everything as expected, but also upload the final release to some server or to some specific platform or anywhere. So, what's the point about that? That if you configure everything, that, as I said, it's a lot of work. You only have to code and push the code or the assets into your repo. And then there is a set of automatic processes that do all the hard part for you, checking the code, compiling unit tests, verifying that everything works, generating the assets, packing the assets, generating the release of the game, and even uploading the release wherever it should be uploaded. So now you probably think in a very small scale, because your projects are very small projects actually, and you keep just compiling it by yourselves in your computer. When you think that they are okay, you upload the changes. Maybe something's broken in the repo, but it doesn't matter. When you have to release the game, you compile in release mode, well, sometimes in debug mode, but it should be compiled in release mode, and then you pack everything into a zip by yourself, selecting all the files and everything. Yeah, in your situation, that's okay because they are extremely small projects. But now imagine a big company, a AAA game, where there are approximately 1,000 people working all around the world in the same project, attacking the same repository and adding changes daily, and keeping in mind that every hour of every person probably costs to the company like $100. Every hour of every person every day costs to the company about $100. They cannot afford at all losing that work or having work that breaks the bill. So it's unbearable at all to have a manual compilation and checking system. So it has to be automated. So continuous integration and continuous deployment is extremely important in medium, I say even small, medium, and big companies. It's extremely important because it's crucial for the process. Well, usually in the companies you have something that's called the build engineers that are the experts in that field. Yeah, that's a job. Okay, so about questions. Can the continuous integration, continuous deployment solve a problem automatically? Usually not, but they let you know that there is a problem. They let you know that there is a problem. They usually you can have, even in some systems, that when there is a problem, they send you an email, they send you a message to the mobile phone to let you know that you push something into the build that broke the build. So they let you know that you have to correct that. Guillem. How much time? How much time it could take? Where if you have some person working full time on that, it could take you, for a simple implementation, 2-3 days. Yeah. Yeah, I mean for your projects. I mean for your projects. So, for example, I was working on that in Electronic Arts, and yeah, we were about 50 engineers out of a team of 400 people working on that. Well, not all the time, but setting up a new build system, having already a lot of templates and everything, usually could take us some days. But having everything from previous projects. Yeah. So, any question? More questions? Well, you have to do that. So a good start is going to GitHub Actions reference page. So this is a good start. okay, listen up. It's not that dramatic. It could take you a bit of work, but yeah, it's not that dramatic. Can you hear me? Can you hear me? Okay, you can check as a reference, well, RightLib. Actually, in RightLib I got a continuous integration and continuous delivery system. It's not the best reference, I have to say that, because I actually there is an open issue here around that says that there is an open issue saying that it has to be finished, so it's not a full implementation, but you can take a look how it's. Oh, there's a question. Wait. Yes. Oh no, Nuria, sorry, I cannot do that because I'm synchronized with Mark on that. Yeah, it's not possible. You can ask Mark about it, but I cannot do it. And we are synchronized the both classes. Just let me finish explain about the GitHub Actions, because you can take a look and you will see that it's not that crazy as you could think. Yeah, but we are synchronized. We are synchronized with the other class, and it has to be this way. I cannot change that. I cannot change dates. Yeah. Yeah. Okay. About GitHub Actions here in RightLib, I got continuous integration for Windows, continuous integration for Linux, and continuous integration for Mac implemented. Okay. The continuous deployment actually it's done through Travis and Abbeyor. Actually, they also use continuous integration. But Abbeyor just it's gonna disappear briefly. So where are the scripts that you have to check? Actually, you can ask Mark about that. You can ask Mark. I don't have those presentations. I don't have those presentations. Okay, GitHub. Here, if you go to GitHub to workflows, here you have the scripts for continuous integration. Let's check continuous integration on Windows. You can check that. For example, that's the continuous integration. Yeah, that's actually what you have to learn to do. That it would have been great to see that code in the presentation, because the dashboard you rarely will have a dashboard to configure these kind of things. You have to learn how to write the code. It's just a script. For example, you name the script, you define when that script runs. For example, push, pull request. Are you following? Hello? Okay. So you define when the script runs. Push, pull request. Push means on any commit, and pull request when there is any pull request in the repo. Yeah, that's it. And here it's the jobs that you have to execute. There is a build job that where it runs. It runs in a Windows latest computer. No, that's it. actually. Enrique, to your question, usually in your project, here there should be, yeah, actions. You see, Enrique, you got here a tab that it's called actions, and here I got the workflows, and you can just check new workflow. And here, for example, it's C, C++ with make. No, we have to look for, there are already a bunch of workflows prepared to start with. There are a bunch of templates actually. Let me check. Node, Rust, Python, build, deploy. You have set a workflow yourself if you want, or try to find a template to compile Visual Studio projects, right? I think that you can try to find an already set up workflow. There is a lot of people doing that, and you can share the workflows, so it's not that dramatic. The idea was that in today's presentation we got a workflow template just to set up, and that's it. If we will have that, it would be just adding the template, and it would have been enough. So actually it had to be something very simple, and now it would take you some work, but it's not that dramatic really. Okay, here you have the workflows. You can choose, for example, that one, and in that workflow I can see the results, but I don't want to see the results. What I want to see is going back into code. When you set up a workflow, a point GitHub workflows folder appears, and here all the scripts for your workflows appear. Right? Are you following me? Please listen up. I'm explaining how to do it. Please. Only you and Rick. Where is the rest of the class? Mikel? Are you following Mikel? Mikel? Are you following Mikel? Mikel? Okay. Okay. So, I show you the workflow, or one workflow for Windows, because it's the workflow that you have to use. That's a continuous integration workflow. I also have here a continuous deployment workflow. Okay. Okay, so yeah, continue. Here you have the continuous integration. Well, in this case, is for my source and examples code for Windows. As I said, you have to set up jobs, you have that build. Here you configure where is this project, this code running, this script running. Here I choose to run on Windows latest. So it's gonna run in a Windows machine with the latest configurations. If you want to know what are the machines where your script will run, you can check it here. Explore GitHub Actions. Here you have a lot of things to explore, but usually you can check. Let me see. The machine specs. No, that's not. Here, software installed. software installed on GitHub hosted runners. Hello? Here you can see all the software. Hello? Hello? What happened? Wait, what? Are you there? Oh, okay. Oh, okay, okay. Are you here? Okay, not sure if you follow that. I was explaining you that sometimes you want to know what software and what configuration you have in the systems where your scripts run. Those systems are in the cloud, right? And usually you want to know what tools you have to run your scripts. So for example, for Windows configuration, it will run in Windows Server 2019. Yeah, and here you have all the information about the things that you have installed. For example, you have installed .NET 4.8, Windows Driver Kit, Android SDK build tools, so you can build for Android on Windows, Android SDK, Azure, Python, Ruby, Perl, Git, Go, Boost, PHP, Rust, Google Chrome. You have all those tools installed in the host system. What would you look for? What are the tools that you are interested in that should be available in the host system to compile your project? Hello? Are you following me? Anyone can answer the question, please? Anyone can answer the question, please? Sure. Okay. Right now, I'm when you configure your script here in GitHub Action to build your code on the push or pull request, those scripts run in the cloud. Actually, it run in some server from GitHub, and that server has some specific configuration. You want to know that configuration because depending on that configuration, your code could be compiled or not. You probably need some tools for that. available in the server. Where can you check that? You can check those tools here in the GitHub Actions help. You got all the different servers available. You got Ubuntu, Windows Server, and Make OS. Here, the one that interests us is Windows Server 2019, because we set up here Windows latest. So our script is gonna run. I think so, but yeah, I think so. I'm gonna share it again. Yeah. So we configure here that this script will run on Windows latest. So if we check here the GitHub host runners, Windows latest will be this one, Windows Server. Okay. If we go to this link, we have a list with all the software installed in that host machine. Okay. In our Michael, what is the question? Well, actually, that's not templates. Those are machines. Those are servers where your compilation process will run. Yeah. So again, I make the question again. For your specific project, what do you have to verify in the server machine? As I said, we already configured here that we are using Windows latest. For your case, you should use Windows latest also. That is this machine, this server. What do you need to verify that it's available in the server? Which software? Here we have Chocolate, Docker, PowerShell. Those are libraries, Mikel. Usually those libraries come integrated with some software. No, you don't need tiled. And XML support is already in your code. It's easier than that. It's easier than that. Think about it, Mark. Actually, there is one main program you use. What program do you use to build your game? Oh, very good, Mark. That's it. Visual Studio, that's it. So we have to check in that list if where is it? Hey, it should be here. Yeah, here. That's what we have. Visual. In that server, we have Visual Studio 2019 Enterprise. So it's the most advanced version of Visual Studio. So yeah, well, we have another things, but yeah, we already have all we need to be able to compile our code. Actually, we also have, look at that, Unity engine, 64 and 86 bits. We have all the components, the Visual SDK, all the libraries that anyone can require to compile their projects. Everything. You see that? So that's it. You should be able to create a build system that compiles in that server. Yeah? Okay. Do you understand? Are you following me? I got some questions, so. Okay. First, I want to note some things. Software that you should be aware of when you work in a big company, because sooner or later you will be using that software. For sure. If you go to a big company and you are artists or you are programmers, never mind, you will be using a lot of software that it's not specifically art or coding software. Okay, so I'll give you a list of some software that you should know about it. First, this one, Chocolate. That's important. Docker. I will explain about some of them. PowerShell. PowerShell is a command line. So for sure you will be using PowerShell at some point. While you got those Docker images. Docker, it's kind of a contained virtual machine. Yeah, that's it. Where you can use to compile code inside. Yeah, okay. Well, obviously Visual Studio, yeah. Wix tools, probably you are not using that. Those tools are to create installers for your game, and they are integrated with Visual Studio, but usually you don't use that. Well, obviously be aware of the net framework. Drivers, you won't be doing anything about drivers. Android SDK, if someone you develop for, at any moment you develop for Android, you will be using the SDK. There are a lot of versions of the SDK. The platform tools of the SDK, also it's a set of tools. Azure, if you have to do something in the cloud. What else? Python. You should know a bit of Python, because sooner or later probably you will be using Python. Well, Ruby, it's not that important. Perl, maybe you have to touch Perl sometimes, but that's horrible. Git, it would be nice if you know a bit of Git command line interface, because maybe you have to use it. The Go language, it's very nice. Well, the Boost library for Microsoft Visual C, maybe you are using the Boost library. PHP, no. Rust, it's an emerging language, maybe. And what else is here? Node. Now there are a lot of compilation processes that run through Node. NPM for package synchronization, also very important. Well, Ant. I hate Ant. Actually, that was the one that uses Electronic Arts, and it's kind of an XML based script configuration system for building. Yeah, I use a lot of Ant. Actually, it was not exactly Ant, it was a variation of Ant. Gradle, it's the Android compilation system. CMake, it's the standard C compilation system. Netcore, well, Netcore now it's not that important, but in a couple of years it will be super important. My MySQL. Maybe you have to do something with databases at some point. MintGW, it's the GCC compilation toolset SDK for Windows, the Linux compilation toolset for Windows. 7zip, you will be using 7zip for sure at some point. Oh, Windows Setup, I didn't know that it has here. Windows Setup, it's a tool to create installers. Actually, I use that for Riley, but in a manual way. It's the way I create the binary for automatic setup the project. It's cool. And yeah, that's it. Those tools that I mentioned are very, very, very important tools that sooner or later you will be using in your career. Be sure. So it would be nice if you had some idea. Keep in mind that you will be working as a programmer. You will be working a lot in the command line, always. Maybe if you start in a small company working with Unity, you won't see anything of all those things. But sooner or later, if you go into a medium big company, you will be using those tools daily. Actually, all the tools I mentioned were standard tools that I was using in Electronic Arts for different things. Every day it was an adventure. No, there is no more presentation, so I'm explaining you all those things because I think it's important to get the idea and to know how to configure your continuous integration and continuous deployment system for your project. Okay, are you following me? Do you have any question? If you want to talk through the microphone, you can raise your hand and I give you microphone access. Okay. Yeah, it's a lot of new info. As I said, it's a wide field. It's a complex topic. But it's super important, really, it's super important for the companies. Because usually when you are a student, you only think about writing code or drawing art. And when you go into a company, most of the time you are not writing code or drawing art. You are dealing with all these kind of things that now are, or you could feel are completely useless. Or you can think that are completely useless, and that's the day-to-day in a company. I mean, keep that in mind. You won't be writing code all the time. Actually, if you are writing code half of the time, that would be very lucky for you. Okay, about all those programs. Those programs are tools. Usually those tools are for automatization. Those tools are for automatization, to automatize processes. Usually you have to do a lot of automatic processes like generate the bill, copy data from one side to the other, compile your code, convert your images between different data formats. There are a lot of automatization in the processes you will be working on, and usually you will use most of those tools for different kinds of automatizations. Sometimes it will come in the form of a Python script, a Rust script, a CMake script, usually an Ant script. You will be using zip to compress some data. You will be using MintGW to compress to compile your code from some specific system. You will be using netcore, CMake also for build a script configuration, or you get a project that uses CMake and you will have to deal with CMake. Gradle, it's the compilation system for Android. Most of the time, yes, Thomas. Well, if you go into a medium or big company, if you go into a small indie company that works with Unity, probably not. But if you pretend to, or you expect to go into a big company, I mean a AAA company, yeah, that's it. That's how things work. As said, for example, in Electronic Arts we use Ant for build systems configuration. Node.js, it's quite common also at this moment. Well, actually, it's interesting to take a look to those tools and to at least have an idea what are they used for, what they use. Okay, so that's we have in our server to use. Now, a question for all of you. Imagine that your project requires some specific tool for some specific process that you have to do in your project, like for example, convert the data to a custom file format. What can you do in that situation if that program is not available in the server where the continuous integration script will run? Did you understand the question? Are you following? Okay, let's see what the students say. I am answering right now. Okay. I'm asking by the way. Pau, what's your doubt? I think you can.
I have
okay.
Already. So the version on the server is obviously Windows Server 2019. I'm guessing that it's not a big issue, the difference of versions between different Windows versions, because they use the same toolset. Or I mean, it's all right. The fact that is
usually the Windows Server 2019 is one of the most advanced Windows versions, and that gives you, it's compatible with, for example, a Windows 10. Well, it's Windows 10, by the way, Windows 10 server.
Yeah, I guess it's Windows 10. Yes, so we don't need to worry that something that may work in the Windows Server version wouldn't work in the home or professional web versions, right?
Yeah. You don't have to worry. You don't have to worry about that. Yeah, okay. That's it. Actually, usually they give you the most advanced equipment to compile your project. The machines they give you to compile your project are usually the most advanced machines and the most widely compatible machines with different systems.
Okay, thank you.
So, yeah, okay. Enrique, I am gonna ask the question again. Okay, as we said, this compilation script, this continuous integration system, will run in one machine. In this case, we configure Windows latest so it will run on this machine. Okay. Okay, for your projects that's very simple because you only require Visual Studio, so that's good. But imagine that you had a project that requires some specific software that it's not installed in this list. It's not installed in the target machine. What can you do? What do you think? No, that's not the solution, Adrian. You need that program for some crucial part of your pipeline, of your build mechanism. So you need it. Jordi, Gita 0 on the vertical slide. Well, that could be an option. Well, Enrique, not really. Actually, the continuous integration system, the only thing that is gonna do is compile your project in a server machine. But that compilation process could require some specific tool that is not installed in the server machine. No. They do not make simulations. They actually compile everything, like it was compiling your computer. But instead of compiling in your computer, it's compiled in a server in the cloud. Yeah, that's it. Yeah, Jordi, Enrique, yeah, you are right. That's the answer. Very good. Yeah, well. Good to see that you are following. Nice. Yeah, you got mechanisms to install the required components or the required software in the server machine. Actually, the server it's kind of a virtual machine, so it can be configured. It got a base configuration, but you can install additional programs if they are required. Yeah, so actually at the beginning I talk about Chocolate. Yeah, you see that? Chocolate. Yeah, you probably don't know that tool right now, but this is an automatic system to install external packages, to install external tools into the server. Yeah, there are a lot of tools available in Chocolate. Just a detail. Actually, I think that RightLib it's available in Chocolate. RightLib it's available in multiple automatic package manager systems. Chocolate it's a package manager system. And I think RightLib it's also available in Chocolate. But well, don't worry for now, because for your project you won't need any additional package to be installed. So let's go back to the continuous integration script. Are you still with me? Are you following still? Yeah, okay. So here you define the strategy for the build process. What's the strategy? Well, if it fails, it does not stop. It continues with the next process. In your case, I think you only have one process, so you don't have to worry much. The maximum number of parallel processes to run, I set up just only process. But for example, if you were compiling your code for multiple platforms and for multiple with multiple compilers and with multiple configurations, they can run in parallel. That's very nice. Yes? Okay. Yes, hello. Hello. Okay. Okay, please give me some feedback, just to know if you are following or something. Yeah. Okay. Well, here I define a matrix of configurations. For example, I define that we should use two compilers, MinGW and Microsoft Visual C 16. So this project, in my case, will be compiled with those two compilers, right? I have to verify that those compilers are available in the target machine, but actually they are. Visual Studio, it's the Microsoft Visual C 16 compiler, you see. But also, I think, yeah, we have got MinGW compiler here. So I set up both compilers, right? Also compile for 32 and 64 bits. So I'm compiling how many times I'm compiling, or in global, how many configurations I'm using to compile my code in this continuous integration system. Let me know. Yeah, that's it. 4 possible configurations. Oh, no. Oh, yeah. Sorry, yeah. 4 possible configurations. Here, I define that, the 4 configurations, some details of the 4 configurations. That's it. For example, generator, yeah, that's it. Here you can configure some external flags for the configuration process, yeah. The steps to run. Here I will define, here are the configurations for the build, and here I define the steps to follow, right? What are the steps? First step. Keep in mind that this script will run in the target machine, right? Right? So I define the steps to follow. First step, checkout. What means checkout? Who knows? Who guesses? What does it mean? Not really. Yeah, that's it. Actually, it's not looking for anything, Pau. What it means is that it has to synchronize that repo into the target machine. You have to download everything into the target machine to start doing things with it. Yeah, it will happen when you do a new push, but the process, what actually does is synchronizing everything in the target machine. So next, the names, I choose the names. Actually, I give the names myself. Second step, you have to. I will run a couple of command line commands that is creating a build directory and going into the build directory. Yeah. It pulls it to the virtual machine. Yeah, that's it. Actually, it's a pull. Actually, yeah. Well, actually, it's called a clone or a checkout. Yeah. Well, that forget about that because you are not using that. And here there is a process that sets up the compiler to use, and there is a process already configured by another user to set up the Microsoft build system. Here will be the process to build with minc.w. Yeah, actually it will be as simple as cd ..writelib. That's the repo that we just check out. We move into a directory and we call a command line compilation process. In that case, that's a condition to run this one. And yeah, those are another process to run if the compiler is Microsoft Visual C. In this case, I'm running those processes like that using the CMake tool, because writelib is configured with a CMake build system. In your case, you don't have the CMake configuration, but you have the Visual Studio project, and you can launch in a similar way the compilation through Visual Studio. You should check that out in your specific case. And well, that's it. Actually, there is no more than that. It's just you just need to understand a bit how the compilation processes work, and configure a script. I say that the script it's a bit complex because I'm doing a lot of things, but in your case, your script should be maybe 30 or 40 lines long. 40 lines, that's crazy. What do you think? You can look into the internet. If you do some research, you will find a lot of scripts to compile a Visual Studio project. A lot of GitHub Actions scripts to compile a Visual Studio project. Yeah, around 40 lines, sorry. I think maybe less than that, because you only have to choose Microsoft Visual C, so you don't need all that matrix, you only need one configuration. Probably you'll need environment flags and the steps, the check maybe the setup environment, and then just one of that. So it's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, maybe it's about 25 lines. Yeah, you can do debug and release also, yeah. You can configure that also. Yeah, it would be nice that you had some kind of template. Actually, that was the idea. But you can ask Daniel for the template. Angel, you can check this script as a reference to learn about it, but not to use, because this script, as I said, is using a CMake based build system, and also it uses a minc.w GW compiler. You only have to use this one, and yeah, but it should be easy to find. Let me check. GitHub Actions Visual Studio C++. Oh, look, Visual Studio setup here. Probably there is. Okay. Look, job. Here you've got already set up job. Oh no, it uses CMake also. No. But GitHub Actions with C++ and CMake, Visual Studio compile, getting started with GitHub and Visual Studio. Yeah, you should probably You have to do some research on that. Oh yeah, Jordi, your question in English. Yeah, that's it, Mark. You only have to use what is available on GitHub, right? GitHub Actions, it's integrated with GitHub, and it's the replacement for AppBayor and Travis, that are another continuous integration systems. No external programs, yeah. Jordi, answering your question. In GitHub, where is the project? Yeah, here, when you are in your project, here you have actions. Jordi, are you here? Here you choose actions, and you can create new workflow. New workflow. Yeah, that's it. You create a new workflow, and that's it. Yeah. And then when you create a new workflow, it will appear here as a workflow, but actually to edit it in the most proper way, you should go to GitHub, workflows, and here you have the scripts. Here you have the scripts to edit. And yeah, and it's already linked to your GitHub project, and you already it already works out of the box, actually. Right? Yeah, well, actually, it's not that crazy, really. It's easier than it seems. As I say, it's maybe a 20-25 lines script, but yeah, you have to learn a bit how it works, learn a bit about the syntax, and yeah, and that's it. And try to find the run command that fits on your configuration, because you are using Visual Studio. So just find the run command that from the command line runs your Visual Studio project and compiles everything. Actually, probably test it, but probably CMake build without the target, probably it would work. Just this one would be the one you need. Give it a try. I mean, that's a good thing, that you can keep trying, and every time you change this file, the script will run, and you will see if it works or not. Yeah, it requires some investigation. Yeah, okay. But also keep that in mind, that video games development, it's a job where you have to keep investigating a lot all the time, because things change, new things appear. 2 years ago, AppBayor was the standard. Now you got GitHub Actions, AppBayor is gonna disappear. So technology keeps evolving, changing. Half of the tools that you have here some years ago were not available, and now they are available. So things keep changing very, 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 very fast. Jordi, you will receive a mail. You will receive a mail, but actually you can also check it here. If we go again to the project actions, here you see the tick. It means that the process worked. Oh, look at that. When I did that commit, it failed. You see? So now, actually I can click here, and you see, oh, 4 completed jobs. All the jobs of that script failed. Let's check, for example, this job. Here you see setup, all the details of the process. Setup, checkout. Here, we synchronize where the file was synchronized in the virtual machine. You see, Environment setup, everything that happened. The process. Here, build process. You see everything. And here you see that something failed. You see, post checkout, complete job. This job failed. Now we can check another one that, for example, this one. That's actually the output of the process. I know that probably at this moment you are not really or not much used to work in the command line and read the outputs and the command line outputs and all those kind of this kind of information, but sooner or later you will deal with that, and you have to learn how to read it and understand oh, what happened here. Okay, I was compiling in this line, I got this problem. Why? What's that problem? It's an error, it's a warning. Did it work? It doesn't work. What happened here? And it's important to learn to read that and follow the issues. For example, as said, when I was in Electronic Arts, I was in the engineering team. We were dealing a lot with this kind of automatic processes. Actually, we not only set up and configure those processes, but also maintain, and they were not that good as GitHub Actions. That GitHub Actions, it's amazing. It gives you a lot of information and everything is so organized. But for example, in our case, sometimes you launch a process that could take, I remember I think it was FIFA 2009 or something like that, that the process to generate, to compile all the code and generate the build usually took about 15 hours. Can you hear me? 15 hours of automatic process. And sometimes in the middle of the process, there were some things that break, and you receive a mail, maybe in the middle of the night at home. We got some kind of feedback to be noticed about that, and you had to try to solve the problem, because the following day there were a lot of people waiting for that build to test or to review or to work on that. So yeah, that's it, how it works. Yeah, it's quite interesting. Sometime at some moment probably you will be in that boat, and you will remember this class, or maybe not. Well, as always, if you have any question, please ask me, let me know, or send me an email. Actually, for a more direct communication, you can contact me through Discord, because I'm usually around in that platform. And well, you can also send me a mail, but sometimes through a mail it can take me a couple of days to answer. So yeah, that's it. So did you understand it? Did you like it? Mixed feelings. Yeah, well, yeah, I understand that it's a lot of information right now. I understand, it's okay, but yeah, just take a look. Actually, it's not that hard to learn and understand. Just take a look carefully. Try to set up some action in your GitHub project. Yeah, when you get the idea, it's not that crazy. It's not that crazy. And actually, I'm not an expert on it. I still learning. I'm also learning about GitHub Actions. There are still some things I want to configure. I don't know exactly how to do that, but yeah, I have to investigate how to do that. Trial and error, you know. Yeah, that's it, man. Yeah, that's what an engineer does all the time. So start. So I think that's all for today. Yeah, we can leave it here, and tomorrow at 8:30 in the morning we will have what we have for tomorrow. Let me see. Research. The audio music manager. Aitor Luque, is that you? Good, very good. That's it. And oh, only that for tomorrow. Oh, yeah. We only have the spatial audio and music manager for tomorrow. Yeah, that's good. That's good. No, I ran out of time, Guillem. I'm afraid I ran out of time. I talked too much today. Tomorrow there will be a surprise attendance. Okay. So yeah, let's stop here for now. Thanks for coming to the class. Hope you enjoy it a lot, and let's work on your amazing GitHub actions. See you tomorrow.